So in this lecture, we'll go with the special functions, which is gamma function and beta function. So let us try to understand what is the gamma function, and then we'll see how we are able to use it for the beta function. So I hope all of you are able to see this Jamboard.
Yes, sir.
Okay. So first we'll try to define what is gamma function. So let us define what is gamma function. Now let n greater than 0. So this is the important condition that we need to understand. N has to be greater than 0. Then the convergent integral. Okay, so what is meant by convergent integral? The integral which has the finite value and we can find it. Okay, so the convergent integral 0 to infinity e raised to minus x, x raised to n minus 1 dx is gamma function of n and is denoted by gamma of n. Okay, so that is way of this is gamma of n is equal to integral 0 to infinity e raised to minus x, x raised to n minus 1 dx. Okay, so that's what we have gamma function. So here we need to be careful. Okay, we are familiar with this gamma. So this is small gamma and this is capital gamma. Okay, so we are familiar with this gamma. So this is small gamma, this is capital gamma. So we have to be careful for the notation. Okay, if your notation is correct, then it will be easy for reader to understand. If your notation is not correct, then it will be difficult. Okay, so what are the properties of gamma function? What are the properties of gamma? So first property that we need to understand is gamma of n plus 1 is equal to n into gamma n. And this is a property we have. Now, how to prove this property? So suppose we'll be having gamma of n plus 1 is equal to, by the definition, what will be having? Integral 0 to infinity e raised to minus x, x raised to n minus 1 dx. Okay, that's going to be the definition of gamma function. So here, if it is n here, then we get n minus 1 here. So what we have n plus 1, and that's why this plus 1 and minus 1 will get cancelled. Okay, so we'll get integral 0 to infinity e raised to minus x, x raised to n dx. So are you getting this one?
Yes, sir.
Is this okay?
Yes.
Yes, sir.
Okay. So now what we know, we have to evaluate this integral. Okay. So we know u into v. So what is u into v? U remains as it is, integral of v minus integration of derivative of u and then integration of v. Okay. So here we have integration of v. So this is the by parts rule, okay, for integration. And if we want to apply this rule, then we have to use either light or highlight. Okay, so what we can have is we can write this integral as integral 0 to infinity x raised to n into e raised to minus x dx. Okay. So what we have here, this is going to be u and this is going to be v. Okay. So let's evaluate this. So what we'll get, u remains as it is, x raised to n, integration of v, e raised to minus x. Okay. And then this will be from 0 to infinity, minus integration 0 to infinity, derivative of u. So what is the derivative of u? N into x raised to n minus 1. And then integration of v. So minus e raised to minus x dx. So are you getting this term?
Yes.
Yes. Okay. So what we'll be having here, this is going to be minus x raised to n, e raised to minus x, limits are from 0 to infinity. This minus and this minus I can make plus, and this n is being constant, we can take it out. So integral 0 to infinity, x raised to n minus 1, e raised to minus x dx. Now let us apply the limit. So when we put this x is equal to minus infinity. Okay, so what we can have is, if I put x is equal to minus infinity, then this will be e raised to minus infinity. So we'll be having 1 upon e raised to infinity, and this is 1 upon infinity, which is going to be 0. So if I put x is equal to infinity, then this will be 0. If I put x is equal to 0, then again this will be 0. So at the upper limit as well as the lower limit, this term is going to be 0. Plus you can have here integral of 0 to infinity, e raised to minus x, x raised to n minus 1 dx. Okay, now if you compare this, so what we get, this is going to be, see, e raised to minus x, x raised to n minus 1, e raised to minus x, x raised to n minus 1. What it is going to be?
Gamma function.
This is going to be gamma.
Gamma.
Okay, so we can write this as, this is going to be n into gamma n. So what we proved that gamma n plus 1 is equal to n into gamma n. And this is what we wanted to prove. And so we proved the first property, that gamma of n plus 1 is equal to n into gamma n. Okay, so here we got this property. Now let us consider the next one. Okay, so what we can have is the second property. If n is positive integer, if n is positive integer, then gamma of n plus 1 is equal to n factorial. Okay, so if n is going to be positive integer, then gamma of n factorial n plus 1 is equal to n factorial. So this is what we want to prove now. So let us try to prove. Okay, what we have gamma of n plus 1. Okay, what we have, gamma of n plus 1, and then we know it is going to be n into gamma n. Okay, so can we write it like this? N into gamma of n minus 1 plus 1. Can we write it like this?
Yes, sir.
Now apply this previous property to this term. So it will become n into n minus 1 and gamma of n minus 1. Is that okay?
Yes, sir.
Yes. So n into n minus 1. And here, this n minus 1, I can write as n minus 2 plus 1. Can we write it like this?
Yes, sir.
Okay. So n into n minus 1. Again, we use the same property. So it becomes n minus 2 into gamma of n minus 2. Okay, what we get is gamma of n minus 2. Okay, so we got n into n minus 1 into n minus 2 into gamma of n minus 2. Okay, so if we proceed this way, okay, then what we'll get is we'll get gamma of n minus 1, n plus 1 is equal to, this will be n into n minus 1 into n minus 2 into n minus 3 and so on. As this n is going to be positive integer, so somewhere it will become like this, 3 into 2 into 1 into gamma of 1. Are you getting this term? Suppose this term is n is going to be 10. Okay, so what will happen? First 10 will come here, then 9 will come here, then 8 will come here, then 7, then 6, then 5, then 4, then 3, then 2, then 1. Okay, and it will become, so what will happen? Gamma of 2. What will be gamma of 2? It will be 1 plus 1. So it will be 1 into gamma 1. And this is what the last term that we are getting here. So is that okay? Is this term okay? Are you able to get this term?
Yes, sir.
Yes, sir.
Okay, so now we have reached here. Okay, so let us think of how we get the next term. So here, what I can do is I can let this equation 1 because I have to find out what is the value of gamma 1. Okay, so I need to find the value of gamma 1, and hence we try to find the value of gamma 1. So how we are able to write the value of gamma 1? Then we have gamma 1 is equal to integral 0 to infinity e raised to minus x, x raised to 1 minus 1 dx. Okay, why this? As we know, the gamma of n is equal to, okay, what is gamma of n? It is integral 0 to infinity e raised to minus x, x raised to n minus 1 dx. Okay, so here the value of n is going to be 1, and hence we are able to write this. So we can write this as integral 0 to infinity e raised to minus x, x raised to 0 dx. And then anything raised to 0 is going to be 1. So here we get only e raised to minus x. And we know what is the integration of exponential term. So this is minus e raised to minus x, and you will be having 0 to infinity. Okay. Now let us apply the limit infinity. So if we apply infinity, this will become 0. Okay. This term is going to be 0. We can say minus 0. And then we are using the lower limit, so it will become minus, and this is minus e raised to 0. Because if I put x is equal to 0, then this will become minus e raised to 0. So what we get here, this is 0 minus minus plus 1. So it is going to be 1. So we got gamma of 1 is going to be 1. Okay, so here we have the relation between gamma n plus 1, and this is also called as following factorial. Okay, so here we have equation 1. This I have equation 2. Okay, so we can use the value of equation 2 in equation 1, and hence we say that using equation 1 and we get, okay, so what we are able to get here, see, this is going to be gamma of n plus 1. Now here what we'll have, n and minus 1 minus 2, so on the term. Finally 3 2 1, and this gamma 1. Gamma 1 also we have calculated, and we got it is going to be 1 only. So what is this number we can have? n into n minus 1 up to 1. So this number is going to be n factorial. So this is going to be n factorial. And hence, what we got here that gamma of n plus 1 is equal to n factorial if n is positive. So this way, we are able to prove the third property also. Now, if we are able to prove this first and second property, then we assume one property and we can prove it, okay, after understanding the beta function. So I will say the third property as let n greater than 0.
Can you please scroll up a little?
Yes. Okay. So you can say that we have gamma of equal to. This is a property. We want to see steps which we also used in the previous. So is there any doubt up to 8?
No, sir.
So is there any doubt up to 8?
No, sir.
No, sir. No, sir. Again, so this property of gamma function that gamma half is equal to root pi. We accept it right now as it is. We will prove after understanding the beta function. Okay, so after understanding beta function, the proof of this becomes very easy to understand. Okay. Now,
Sir, is that under root pi?
yes. Okay, so we have to be careful for root sign and for the gamma sign. Okay. Yes. Okay. So we need to understand that this is the sign for gamma function and this is square root. Okay. So gamma of half is equal to square root of pi. Okay. Now, as I said, this property we'll prove later. Okay. So we should not mix with the square root and the gamma. Okay, so whatever the properties of gamma function we have seen, that properties the root will not have. The root has the different property as it is a different function. Again, we should not treat gamma function as we treat the root. Okay. Now let us try to understand the different problems that can be solved using gamma function. Okay, so let's go with the first one. Having that I is equal to integral 0 to infinity ax raised to n dx. Okay, this is the integral that we want to solve. Okay, so if it is integral e raised to x dx, it becomes easy to solve. But when we have here we have some other power, then this will not be possible. Okay, and that's why we need to understand how gamma function can help us. Okay, so if we compare this definition, integral 0 to infinity e raised to minus x, x raised to n minus 1 dx, this is going to be gamma n. Okay, now this integral, if we see, we have exponential raised to variable. Okay, we must have exponential raised to variable
to apply this. Okay, so here we have exponential raised to a into x raised to n. Okay, so this term should be changed to the variable. And hence, what we can do is we can put y is equal to ax raised to n. So if I put y is equal to ax raised to n, what will have x raised to n? It will be y by a. And what will have x? It will be y raised to 1 by n on a raised to 1 by n. So this is x we can have. Now, think of the derivative dx. So this term we are able to replace. What will be dx? So we can have dx is equal to 1 upon a raised to 1 by a is constant, and we'll be having d by. Now we have to consider the derivative. So the derivative of y raised to n. Okay, we can have the derivative of y raised to 1 by n. So it will be 1 by n e by dy. Okay, so here we have derivative is y raised to n minus 1 and dy.
What?
Are you getting this? This will be
Sir, it will be 1 by n.
Yes, sir. 1 by
will be 1 by n minus 1. Is that okay? Are you getting this?
minus 1 will be separate term.
So we have 1 by n minus 1, right?
Yes, sir.
Now we are able to replace this term. We are able to replace this this dx term. Okay. So we have to think of what is the limit. Okay. What will be the limit when we change x to y? Okay. So we have x and we have y. X is running from 0 to infinity. Y will be also running from 0 to infinity. Okay. Because see, if I put x is equal to 0, this y will be 0. If I put x is equal to infinity, whatever the value of a, this term is going to be infinity. So we got when x is going to be 0, y is going to be 0. When x is going to be infinity, y is going to be. Is that okay?
Yes, sir.
So after this calculation, we have we will be having the integral I, it will be 0 to infinity. E raised to minus y. And here, what will be having? Y raised to 1 by n minus 1 for n a raised to 1 by n dy. Is that okay? So this term will get replaced by y and dx. So dx we have calculated here. So it will be n into a raised to 1 by n. And this term remains there. Okay. So what are the constant terms? 1 upon n, a raised to 1 by n, integral 0 to infinity. And what we have here? Y raised to 1 by n minus 1. And you are having e raised to minus y. So here we have e raised to minus y and this is going to be dy. Compare this with the definition of this integral. So what this integral will be?
Sir, the integral will be 1 by n into the gamma function. Hello.
Yes.
It will be 1 by n gamma in the gamma function.
So it will be gamma of n and divided by divided by y raised to n.
It will be if you compare this. Okay, instead of n, we have 1 by n.
The gamma of 1 by n will come.
So it will be 1 upon
n a raised to 1 by n, and this will be gamma of 1 by n.
Yes.
Okay, so here we have n, here we have 1 by n. Okay, so if we compare these two integrals, then instead of n, we have 1 by n. So it will become gamma of 1 by n. So this integral becomes, okay, what will become 1 upon n a raised to 1 by n, and here we have gamma of 1 by n. Provided that this n is going to be positive. Okay, because without n is positive, we cannot have the definition of gamma function. Got it? Is there any doubt?
No, sir.
All of you got this one?
Yes.
Yes, sir.
Now we have considered only the term exponential. So we got here
Excuse me, sir.
as, yes,
Sir, we can also write it as 1 upon a to the power 1 by n into gamma of 1 by n plus 1.
yes, we can write it like that. Okay, so this 1 by n, you can take it inside. So obviously, you can write it as 1 upon a raised to 1 by n, and if you want, you can write it as like this. This is what you want to write, no?
Yes, sir.
Yeah, definitely we can write it. Okay, so here we got the integral 0 to infinity e raised to minus x raised to n dx is equal to 1 upon n a raised to 1 by n, and this is gamma of. Okay, so we solved this integral actually. Okay, and we know we can use the value of gamma 1 by n if n is small. Okay, and without loss of generality, we consider that n is going to be positive. N is going to be positive number. Okay, so it may be rational, it may be real. Okay, but n is positive. That is important. Okay. Now let us think of the next. Okay, what we can do is we'll add one more term. Okay, so we try to add one more term. Okay, so we go with the next. What we can say is let I is equal to integral 0 to infinity e raised to minus a x raised to n into x raised to m dx. Okay, so suppose we have this earlier term and we multiply this earlier term by another algebraic function. Okay, so how we are able to find this integral? Okay, so let us think of it. So substitution is going to be same. So for the substitution, what we have to do is we have to consider the exponential function, and the power of the exponential function has to be the variable of integration. So if it is a variable of integration, then easily we are able to integrate. Okay, so here again we use the same substitution that a x raised to n. So what we can do is put a x raised to n is equal to 1. And we know about the limits. Okay, so x is x and y. Okay, what we can have is x is 0. And here we'll be having x is. So what will be the value of y? You guess the value of y. X raised to n is equal to y.
It will be 0, sir, for x equals 0.
So for x is equal to 0, it will be 0. For x is equal to infinity, it will be infinity. Getting this one?
Yes, sir.
Yes,
Getting this? Yes. Okay, so what we can say is x raised to n is equal to y by a. So you got x equal to this term you are having 1 by a, or I can write
I
this
raised to
as
1 by n.
y by a bracket raised to 1 by n. So it is y raised to 1 by n and a raised to 1 by a. Now, if we want, we got x is equal to x is equal to 1 upon a raised to 1 by n, y raised to 1 by n. Okay. Now think of its derivative. So we can have x raised to n is equal to, this term is going to be y raised to 1 by m upon term is exponential. We are putting this term. So what we'll get here, this x raised to m is this term, which is x raised to m. So y raised to 1 by n, a raised to 1 by n, and this raised to 1 by n. Is that okay? Here, this m, we can write it like this. Getting this one? Are you getting this one? Yes. Okay, so I can write this as, this is equal to y raised to, we have here, this is now,
Sir,
yes, wait. Okay, so x raised to m we want. Okay. So y raised to m by n and a raised to m by n. Is that okay?
Yes, sir.
yes, sir, now it's okay.
So we got x raised to m is equal to y raised to m by n and a raised to m by n. Here we got the term x. Okay, we got the term. Now we have to think of dx. So let us differentiate this. Okay, so if we differentiate this, what we'll get is dx is equal to 1 upon. So we got here this term by n will come down. Then a raised to by n we have a raised to 1 by n and the derivative of this. So is that okay? And here
Yes,
what we
sir.
have the numerator. The numerator will be y raised to by n minus 1. Okay. Are you getting this step?
Yes.
We are differentiating this with respect to, so on this side we are differentiating with respect to x, on this side we are differentiating with respect to y. Okay, so you got dx is equal to 1 upon n, a raised to 1 by n, y raised to 1 by n minus 1 dy. Getting this one? Are you getting this one?
Yes,
Yes. Yes, sir.
So we got x, we got dx, and we got x raised to. Okay, so we got almost everything that is required, and hence we can say, so we get y is equal to. Okay, so what is the term we are having here? See, limits are going to be 0 to infinity, so here it will remain 0 to infinity. So we have here, this is 0 to infinity, e raised to minus y.
Okay, and now exponential term. So this is what we got here. What about this term? So it is y raised to 1 by m. And here it will be precisely n by m. Okay. So we got here y is equal to m by n. Now, this is the next term we'll be having here. This is a raised to m by n. Is that okay?
Yes, sir.
We're getting this one. Okay, and now
Yes.
what we want, we'll have this is 1 upon n, a raised to 1 by n, y raised to 1 by n minus 1. Are you getting this now? Is there any doubt up to it?
No, sir.
Now let us simplify this. Okay, this is equal to integral 0 to infinity y raised to m by n upon a raised to m by n. 1 plus, okay, or you can have here as, see this dy terms. Okay, so it is e raised to minus y. Now this term. So what will be having y raised to 1 by y minus 4. And here what will have n into. This is always that we have considered. Okay. So here we'll be having n into a raised to 1 by n. And we have here. Now let us calculate the value of this integral. First, we need to simplify this integral. Okay, so how we are able to simplify? See here, integral 0 to infinity, e raised to minus 1, y raised to m by n. So the power of y is divided by, so here y raised to 1 by m, e raised to minus y, a raised to m plus n. So now you get here, we'll have y raised to m by n. And here, what is the term you'll be
Sir?
having here? Yes.
Sir, how come a raised to m plus n?
Okay. So here, what we'll have here? This is going to be m by
m
plus one.
plus 1
n
by
plus
plus
1,
Sir,
m plus
Yes, sir.
1 by n.
1 by n.
yeah,
Yeah.
sir, there it is 1 by n, a raised to power 1 by n in the left equation.
So what we get here is going to be, this is
No,
m
they
by
are
n.
not.
This is
Little
m by
right.
n. This is 1
Yes,
by
yes.
n. Okay.
Yes.
Sum is going to be 1 by n. Okay. Now this is a raised to m by n plus 1 by n. This is y raised to m by n by m by n, and this will be 1 by n minus 1 and dy. Is that okay? Are you getting this now?
Yes.
And we'll be having
Yes, sir.
here n again. Okay, this n remains, right? Okay, so what we'll be having? 1 upon n into a raised to m plus 1 by n. Is that okay?
Yes.
This is integral 0 to infinity e raised to minus y raised to m plus 1 by n minus 1 dy. Are you getting this term?
Yes, sir.
Okay. You can say this is m by n. And so if we compare this, Okay, 1 upon n a raised to m plus 1 by n. Then this integral is gamma of m plus n by 1 by n. So is that okay?
Yes, sir.
Because what we do is we always compare to the definition of gamma function. And if we compare to the definition of gamma function, then this term turns out to be n. Okay. So this we can write as gamma of m plus 1 by n. So here what we calculated I is equal to calculated 1 upon n into a raised to m plus 1 by n, and this is gamma of m plus 1 by n. So we proved that the integral 0 to infinity e raised to minus ax raised to n into x raised to dx. This is now 1 upon n a raised to m plus 1 by n, and this is gamma. This is going to be gamma of m plus 1 by n. Are you getting this one?
Sir,
Is there any doubt in this example?
for m equals to 0, we should get previous case, isn't it?
No, n cannot be 0. Okay, because here, if we put n is equal to 0, then this will become e raised to minus
M.
0.
I am saying
Yes.
m.
M.
Mumbai m.
If you put m is equal to 0, then it is the previous case, right?
Yes, sir.
Okay. So that's right. We will get the previous case if m is going to be 0.
Excuse me, sir.
Yes.
Sir, I am having a doubt in writing a gamma function. That means just we write like a square root, or it is beside f of x like.
This is the way to write gamma. Okay. So it
Below
is
it.
gamma of n. So we write this n inside the symbol of gamma. So like we write a square root of n, no? We do not write square root n. So we write n inside the square root. So the same way we should write n inside this gamma.
Because on the Google it was showing beside it now like f of x. That's why.
Like gamma or n, like this.
Yes, sir.
Okay, no, it should be written like this. Okay, may
Okay, sir.
possible that this gamma sometimes people do not get the proper symbols. Okay, so that's why they write it like that. Okay, but it should be like this. This is the correct way to write it. Okay, as this is not correct, this is the correct way. So this is not the way, but this is the correct way. Sometimes it is written like this. Okay, so when the person is not able to type it properly, so he will do like this. Okay, even though many of the people do not get beat up in typing, that's why they write capital B in bold. Okay, but actually it is going to be B. So is your doubt clear now for writing gamma function?
Yes, sir.
So all of you got these two integrals.
Yes, sir.
Okay. So what is the basic requirement? The basic requirement is we must convert, okay, the power of exponential to be the variable, and then whatever the power of variable we have, we don't have to worry about it. Okay. So now think of the another integral. Okay. So let's go with another integral. Right. I is equal to
integral 0 to 1 x log x raised to m. Okay. So suppose we want to solve this integral using gamma function. So what is the requirement of the gamma function? So it is integral 0 to infinity e raised to minus x, x raised to n minus 1 dx. Is this going to be gamma of n? Now see, we need the limit 0 to infinity. Then we need the exponential term. And we have the power of the variable. Okay, or exponential function is the minus sign of variable. Now, can you tell me which of these terms? So integral 0 to 1 x raised to m log of x raised to m dx, you are able to convert to the exponential. So which of these two functions will get converted to the exponential?
So log of x can be
Log of
considered
x.
as t.
Log of x raised to the power 10.
Right. So log function can be easily converted to exponential as it is the reciprocal, or we can say the inverse of the exponential. So here what we do is, okay, this is the integral I. So what we do, put log x is equal to t. So if I put log x is equal to t, what I am able to get is x is equal to e raised to t, right? But if you see the definition of gamma function, we want e raised to minus variable. So this t is not sufficient, it should be minus. Got it? And now we have to think of the limits. Okay, so x is going to be 0 to 1. What is the value of t? Now see, x is equal to e raised to minus t. We want what is the value of t. So if x is equal to 0, so this term is going to be 0, this is going to be e raised to minus t. Is that okay?
Yes, sir.
Yes, sir.
So this will be 1 upon e raised to t. Is that okay?
Yes, sir.
Yes, sir.
So 0 is equal to 1 upon e raised to t. I can write this as e raised to t is equal to 1 upon 0, which is infinity. So e raised to t is infinity. This implies that e is equal to. So is there any doubt? Is there any doubt that t is going to be infinity when x is going to be 0?
No, sir.
No, sir.
Okay, so we have taken x is equal to 0 and then we simplified that t is going to be infinity. Okay, now think of the next. Okay, so what is the next limit? T is going to be 1. So x is going to be 1. So x is 1 and this is e raised to minus t. So can I write x is equal to e raised to t?
Yes, sir.
Okay, and if I take log on both sides, so is it t is equal to log 1?
Yes, sir.
What is the value of log 1?
0.
0. So that means this is going to be 0. Is that okay? Now see, we got both the limits. We got upper limit as well as we got the lower limit. Now, what will be dx? So is dx e raised to minus t, e raised to minus t dt? Are you getting this derivative?
Yes.
Yes, sir.
Yes. Okay, so we can replace the term log x, we can replace the term x, we know the limits, and we know how to replace this dx. So we can rewrite the integral as, okay, so how we are able to rewrite this integral as, and hence we can say we have I is equal to, please be careful, don't be in hurry. What are the limits? The limits are infinity to 0. Because when lower limit x is equal to 0, the lower t limit is going to be infinity. When x is going to be 1, the t is going to be 0. So here we have the limits as infinity to 0. Okay, so if we have infinity to 0, what are the terms we'll having? X. X is e raised to minus t raised to m. Log x. Log x is minus t e raised to m. Okay, and now what we get here? This dx. So this dx is minus e raised to minus t. Okay, and here we get dt. Is that okay? We're getting these terms. I replace
Yes,
x
sir.
by e raised to minus t. I replace log x by minus t, and this dx by minus times e raised to minus t dt. Is that okay? Now simplify this. Okay, so what we get? I is equal to integral infinity to 0 e raised to minus mt. This minus 1 raised to m e raised to going to be, okay, so this is e raised to m. Okay, now can we absorb this minus sign so that these limits can be changed? Okay, what we know is
Excuse me, sir.
Yes,
minus time, just wait. Okay, minus time b to a is nothing but the integral a to b. Okay, so now what is your query?
No, sir, I got it. Thank you.
Okay. So this minus sign I will absorb and change this limits. So what we'll have here, this is equal to 0 to infinity e raised to minus mt minus 1 raised to m e raised to m, and this is minus e raised to minus t. So is that okay? This 1 minus sign we have absorbed and we have made it from infinity to 0. We make it 0 to infinity. Okay, so here this minus 1 raised to m is a constant. Integral 0 to infinity e raised to m and e raised to minus m plus 1t. Is that okay? Are you getting this integral?
Yes, sir.
Yes,
So,
Excuse me,
sir.
yes,
sir. In first step, we have written infinity to 0,
yes,
I equal to.
yeah. The first step we have written infinity to 0. Because see, here what we can have is when x is equal to 0, t is going to be infinity. When x is equal to 1, t is going to be 0. Okay, so that's why we have to write here infinity to 0.
Okay, sir. Thank you.
Okay, is there any other doubt? Okay, so we go to the next step. Now simplify this. So we can have minus 1 raised to m integral 0 to infinity e raised to minus m plus 1 into t. So here our variable is going to be t. Okay.
and then what we have e raised to m dt. Is that okay?
Yes, sir.
Now see, this integral looks like a type 2 integral, whatever we have seen earlier. So what we have to do here, put again m plus 1 into t is equal to y, so that we can have y is equal to, this is going to be t is equal to, what will be having y upon m plus 1. Is that okay? So we get here t is equal to y upon m plus 1. And hence, what will be dt? Dt will be dy upon plus 1. Is that okay? And then the limits. So what do you have? Y is 0 to infinity. Then we have y e as 0 to infinity, y will be also 0 to infinity. Is that okay?
Yes, sir.
Are you getting this?
Yes, sir.
Yes. Okay. So now we can replace this term, we can replace this term. Okay. So we can write here, hence we get I is equal to, this minus 1 raised to m remains as it is. This is 0 to infinity. So what is the term we'll be having here? E raised to minus y. Okay. Then what we have t is going to be y upon m plus 1 raised to m. And here we have ey upon m plus 1. Is that okay? Okay. So this is what you will be having. Now simplify. So this is minus 1 raised to m, integral 0 to infinity, e raised to minus y raised to m, on, will be having m plus 1
Sir, it will be e raised to the
m
power minus y.
minus, yes. Okay, so this will be m plus 1 bracket raised to m. And again you have m plus 1. And this is going to be dy. Okay, so if we simplify, we have minus 1 raised to m plus 1 raised to m plus 1. And this is 0 to infinity. E raised to minus y raised to m. And this is going to be. So can you guess what this integral is going to be?
Sir, gamma of m
Gamma
plus 1.
m plus 1.
Correct. So this will be gamma of m plus 1. And here we have upon m plus 1 raised to m plus 1. Okay, so actually what we had this integral 0 to 1. Okay, and then we converted it to gamma. So after converting to gamma, we are able to get this value. Okay, so we got here, hence integral 0 to 1 x log x bracket as to m dx is equal to. So we got here, this is minus 1 raised to m gamma of m plus 1. M plus 1 raised to m plus 1. Okay, and this is what we are able to do. Yes.
Sir, this answer can be reported in more two forms, no?
Okay, how you can write this?
Like gamma of m plus 1 can be written m gamma.
Yeah, that is always possible. Gamma of m plus 1 or n plus 1 is can be written as n
Also is
into
m
gamma of
factorial.
n. Okay, that's true. But here we don't know what is m. M is going to be integer or not. So let it be as it is. Got it?
Okay.
Now we got the idea about log x. Okay, what if we have log of 1 by x? So let I is equal to integral 0 to 1 log of 1 by x bracket is to. Okay, so you can see earlier it was log of x, now it is log of 1 by x. So we can simplify this as integral 0 to 1. Yes.
Can you give us
Yeah. So let us see this example. Okay. Here, what we have the integral 0 to 1 log of 1 by x bracket raised to m dx. So if we look at this, can we write it like minus log of x bracket raised to m dx? Is that okay?
Yes, sir, we can write it.
Okay, because we have log of 1 by x is same as log of x raised to minus 1. So we can have minus log of x. Now, if I have I is equal to this, so again we can put this log x is equal to minus t. So x is equal to e raised to minus t. Dx is equal to minus e raised to minus t dt. And the change in limit, okay, is going to be x is 0 to 1, t will be infinity to 0 as earlier. And here we can have this minus log x is equal to t. Okay. Now we can replace dx, we can replace log x, and we can rewrite this integral now. Okay, so let us try to rewrite this integral. Hence, we get I is equal to integral infinity to 0 e raised to m minus e raised to minus t. So we can write this as integral 0 to infinity e raised to minus t raised to m dt. Is that okay? We're getting this because what I did is I absorbed this minus sign and changed the limits. Okay, so we get here, this is integral 0 to infinity e raised to minus t raised to m dt. So can you guess or can you relate what this integral is?
Gamma m plus 1.
So it is very simple that gamma m plus 1. Okay, so here what we got? We got I is equal to gamma of m plus 1. So actually we were solving the integral 0 to 1 log of 1 by x bracket as to m dx, and this is going to be gamma of m plus 1. So this integral was discussed by Euler in his one of the letters to Narendrakumar, and from this integral all the definition of the gamma function came into picture, and then it was defined as gamma. Okay, so we got the idea for this integral. Okay, now think of the next integral. So suppose we have integral I running from 0 to infinity, x raised to a upon a raised to x dx. Okay, this is the integral that we want to solve. Okay. Now, what we know about the integral gamma n. So, integral we have, this is 0 to infinity, e raised to minus x raised to n minus 1 dx is equal to gamma n, right? So, can we write it as integral 0 to infinity x raised to n minus 1 upon e raised to x dx is equal to gamma n? Is that okay?
Yes.
Yes, sir.
If you know the definition, then this integral can be solved easily. So compare these two integrals now, how we are able to convert this integral to gamma. And the hint is the denominator. Okay, so what we have to replace is the denominator should be the exponential term. So what we can do is put a raised to x is equal to e raised to y. What we have to do is put a raised to x is equal to e raised to y. So taking log on both sides, what we get, x log a is equal to y. Now, what about the limits? So you'll be having x is 0 to infinity, y will be 0 to infinity. And hence x is equal to y upon log of a. So dx is equal to dy upon log of a. So we know the value of x, we know the value of a raised to x, we know the value of dx. So we are able to rewrite this integral. And hence, what we can say is, we have, okay, so what we'll get here, integral I is equal to integral 0 to infinity. See this x, so x is y upon log of a bracket raised to a, 1 upon e raised to y, and this is dy upon log of a. Is that okay? Are you getting this? So we have replaced x term here, we have replaced a raised to x here, and we got dx. So we can write this as integral 0 to infinity y raised to a log of a raised to a e raised to minus y dy upon log of a. Is that okay?
Yes, sir.
So we can write I is equal to. So this is log a raised to a and this is log a again. So can we write it as log of a bracket raised to a plus 1 and the integral 0 to infinity e raised to minus y raised to a dy. We write it like this. Is that okay?
Yes, sir.
Yes, sir.
Yes, sir.
So compare this integral. What this integral is going to be?
Sir, gamma of
Gamma
a
of
plus
a
1.
plus 1.
Plus 1.
Right. So it is going to be gamma of a plus 1. And here we have log a bracket raised to a plus 1. So this way we are able to get I is equal to gamma of a plus 1. And here we have log of a bracket raised to a plus 1. So we got integral 0 to infinity x raised to a on a raised to x dx equal to gamma of a plus 1 upon log of a equals to a plus 1. So this way, we are able to solve the problems based on gamma. So here, whatever the type of problem we have, okay. So either we have only exponential term, or we have exponential term with one more term, or we have log term, or we have log of 1 by x, or we have x raised to a upon a raised to x. All these integrals we can convert to gamma. And then once we get in terms of gamma, we are able to simplify them by using the properties of gamma function. So is there any doubt up to a?
Sir, are we supposed to memorize these results of integrals?
No, you are not supposed to memorize this result. Okay. So here we are trying to get the idea how gamma comes into picture, or how to convert these integrals to gamma. Okay, that we have seen in these examples. Okay.
Okay.
So you are not supposed to memorize anything. You are supposed to understand the definition of gamma function only. And once we understand the definition of gamma function, so you can see in each on every example, I am using the definition of gamma and converting everything to gamma. Got it?
Yes, sir. So we need to understand the conversion skill.
Yes. You need to understand where we want to go so that you can get what we have to substitute easily. Okay. Okay, let us try an example. Okay. Evaluate integral 0 to infinity e raised to minus x raised to 4 dx. So this is the integral that we want to evaluate. So let I be the integral 0 to infinity e raised to minus x raised to 4 dx. Now what is our target? Exponential, the power of exponential function should be only minus variable. So that means this we have to be placed as a variable. So what we can do is put x raised to 4 is equal to y. So what you will get? X is equal to y raised to 1 by 4. So dx is equal to 1 by 4 y raised to 1 by 4 minus 1 dy. Is that okay? Are you getting this?
Yes, sir.
Yes, sir.
Okay, so think of the limits. So x is running from 0 to infinity, y will be also running from 0 to infinity. Always write the limits, because we know in some of the examples the limits are changing. So we must write the limits. And then we got this term, we got a dx. So we have, what I will get is I is equal to integral 0 to infinity e raised to minus y 1 by 4 y raised to 1 by 4 minus 1 dy. Is that okay? Are
Yes,
you
sir.
getting this? Yes. So we can write this as in 1 by 4 integral 0 to infinity e raised to minus y raised to 1 by 4 minus 1 dy. Okay, and now we know the integral 0 to infinity e raised to minus x raised to n minus 1 dx. This is going to be gamma of n. Is that okay?
Yes, sir.
So what this integral will be?
1 by 4 into gamma 1 by 4.
So it is
Gamma 1 by
yes. This
Gamma of
integral
1 by
is going
4.
to be gamma 1 by 4. So we got the value of integral I is going to be 1 by 4 into gamma 1 by 4. So what we got? Integral 0 to infinity e raised to minus x raised to 4 dx. This is going to be 1 by 4 gamma of 1 by 4. Okay, so if we know the value, then only we have to use this. Okay, so gamma function is different than the square root. Okay, so if we have square root of 1 by 4, then what we'll do is 1/2 into 1/2, or we can write it like this. Okay, so we can write that 1 by 4 as 1/2 into 1/2. Okay, and we can write this will be root of 1/2 into root of 1/2. Okay, but in gamma, you cannot write like that. Okay, so gamma of 1 by 4, and if you write it is gamma half and half, and then you say it is gamma of half into gamma of half, then not possible. Okay, so square root has different properties, gamma function has different properties. So if we know the value, and what value is known, gamma half is known. Okay, so here, if you know the value, use that value. If you don't know the value, let it be as it is. So saying that gamma 1 by 4 is sufficient. Okay, we don't have to find value of what is gamma 1 by 4. Yes.
So we can write the answer we have got like gamma of 5 by 4, right?
Yeah, it is same. Yes, that's true. Actually, gamma of n plus 1, this property is used to express as n into gamma n. Okay, so
Okay.
you are using it either way. Actually, it is this way, but that doesn't matter. Both are equal, so we can say yes.
Okay, sir.
Okay, this property is to simplify. Okay. So, is there any doubt in this example?
No,
Okay.
sir.
So we go for the next.
Sir,
Yes.
before we proceed, I had a doubt. We have studied this property gamma of n plus 1 is equals to n factorial.
Yes.
But we can't use this property here, right? Because 1 by
Yes.
4 is not integer.
Yes, that's true. So when we have studied this property, there is a condition that we have put.
Should be positive integer.
Yes, when it is positive integer, then only that is applicable. Okay, so if it is not positive integer, then it is not applicable. Then only it will convert to this way, no? Then only it will go to 1 and gamma 1. If it is not a positive integer, then it will not get converted to 1. Okay, suppose n is going to be fraction. So if n is going to be suppose 5 by 2. Okay, what if then we use this property 5 by 2, then it will be 3 by 2 into gamma 3 by 2. Then 3 by 2 is again half into gamma half. Okay, so there it will not be factorial. It will be factorial in the case only if this n is positive integer. Got it?
Yes, sir.
Okay. So now let us try another example. Okay, evaluate integral 0 to infinity e raised to minus x square x for x square, and here for x raised to 4 and x square dx. So this is what we know. Okay. We evaluate this. So what we get here, let I is equal to integral 0 to infinity e raised to minus x raised to 4, and we have x square dx. So what we have to do is we have to replace this as a variable. So put x raised to 4 is equal to y. So x is equal to y raised to 1 by 4. And hence we can write dx is equal to 1 by 4 y raised to 1 by 4 minus 1 dy. Okay. That's what we have. Now think of the limits. So what are the limits we'll be having? X is 0 to infinity, y will be 0 to infinity. And then x square. So what is x square? x square is y raised to 1 by 4 its square. So it will be y raised to half. Is that okay?
Yes, sir.
Okay, are you getting this one?
Yes.
So it is 1 by 4 raised to 2. That means it will be half. So we get I is equal to integral 0 to infinity. Okay. Then e raised to minus y raised to half. And here what we have, this is 1 by 4 y raised to 1 by 4 minus 1, and you'll be having dy. So if we simplify, what will be having here? 1 by 4. This is 0 to infinity. E raised to minus y. So what is the term you'll be having here? So this half and this 1 by
3
4.
by 4 minus 1.
Yes. So 3 by 4 minus 1 dy. So what is the term you'll be having here? This is going to be 1 by 4, and this is
Gamma
3 by
Gamma
4.
of 3
Gamma
by
of 3 by 4.
correct. So we get here this I is equal to 1 by 4 and gamma of 3. Okay. So we got integral 0 to infinity e raised to minus x raised to 4 x square dx is equal to, we get here, this is 1 by 4 and gamma of 5. So this way we are able to evaluate this integral. So is there any other doubt up to a? Is there any doubt up to a?
No, sir.
Sir, can you scroll up a bit, please?
Yes. Yes.
Thank you, sir.
Sir, how to calculate gamma of 3 by 4?
No. For that,
Yes,
we
sir,
need.
I have the same doubt.
Yes. Yeah. That's what I said. If you know the value of gamma, then use it. If you don't know the value of gamma, then let it be there. Okay. So if you want to calculate this value, then we have to go to the discrete definition or the Meta-Leffler function and all in fractional differentiation or in fractional calculus.
Sir, but that is not there in syllabus, right?
Yes, that's true. Okay. So are you done with this example?
Yes, sir.
Okay. So let us think of another example. Okay. So suppose we want to evaluate. So we have evaluate integral 0 to 1. So x log x bracket is to 4 dx. Okay. So we can go with the solution as what will be having let I is equal to integral 0 to 1. So you got here x log x bracket is to 4 dx. What is the substitution? Put log x is equal to minus 3. So what we get here? X is equal to e raised to minus 2. Then what are the limits? So here x is running from 0 to 1 and t is running from infinity to 0. Okay, so we got x here, we got log x. What will be dx? So dx is minus e raised to minus t dt. And hence we get. So what we are able to get here, see, I is equal to integral infinity to 0. Okay, we have the term x. So it is e raised to minus t raised to 4. And this is minus t raised to 4. And this is minus e raised to minus t dt. Are you getting these terms? Because we have x raised to 4 and log x raised to 4. So x is e raised to minus t raised to 4. And log x is minus t raised to 4. Okay, so this minus sign can be absorbed to change the limit, and we can write 0 to infinity e raised to minus 4t, e raised to 4, and e raised to minus t dt. Is that okay? Are you getting this term?
Yes.
Okay, so we have this is the integral. So this e raised to minus t and this e raised to minus 4t, we can add up and then we can have e raised to minus 5t. Now we got I is equal to, okay, so integral 0 to infinity e raised to minus 5t e raised to 4 dt. So again, this we have to change to variable. So we can put 5t. Okay, so this is going to be 5t is equal to y. So t is equal to y by 5. And then dt is equal to dy by 5. Okay. Now, what will be the limits? Okay, so here t is 0 to infinity and y will be also 0 to infinity. So we get I is equal to integral 0 to infinity e raised to minus y by 5 raised to 4, and this is dt. So dt is dy by 5. Okay, so we can write this as 0 to infinity e raised to minus y raised to 4, y raised to 5 dy. Is that okay? So it is 1 upon 5 raised to 5 integral 0 to infinity e raised to minus y raised to 4 dy.
It
So
will
what is
become
integral is?
gamma of 5.
Correct. So this is gamma of 5 and this is 5 raised to 5. So gamma of 5 is 4 factorial and this is 5 raised to 5. So it is going to be 24, and what is 5 raised to 5 is going to be? Right?
Three one two five.
It is going to be 3125. Okay. So here in this case, you got the value as I is equal to 24 and this is 5 even. Okay. So here we calculated the integral 0 to 1 x log x bracket raised to 4 dx, and this is 24 by 3125. So as I said, if you can calculate the value of gamma, calculate. If you don't know, then let it be. So in the previous cases that we were having gamma of 1 by 4 or gamma of 3 by 4. So we don't know the value of exact value. It can be approximated, as I said again. So we don't know the exact value of that. So let it be as it is. And it is expected from you that you let it be as it is. Okay. So is there any doubt up to 8?
No,
No,
sir.
sir.
That's good. Yeah.